Hi guys, we're solving quadratics in this video. This is part 2 of quadratic word problems. I'm still fighting my pen for my Windows Surface, so I'm using a tablet, so we're going to have to fight through that. But hopefully this video won't take that long and you can watch these two separate videos in a little bit more of efficient fashion than watching them both at the same time. So let's get started. Alright, so in my last video I covered in detail this projectile motion organizer. What my students are given this, if you don't have it, I recommend you take a screenshot of it or print it out. It's amazingly helpful, I think, in figuring out what you need to do for what the question is asking. I go into it in some detail in the previous video, so you could check that out if you like. Alright, let's get to the first example. Okay, so we're launching a toy rocket vertically upward from the ground level with an initial velocity of 128 feet per second. Then its height h after t seconds is given by the equation. H equals negative t squared plus 128t. What is the maximum height and when will it reach it? So we go back to our projectile motion organizer, and at the highest point, which is the vertex of the quadratic function, it says find the axis of symmetry, then plug the axis of symmetry in for time. So let's take a look how we're going to do that. In my previous video, I state that you can find the vertex two ways. One of them is to use the axis of symmetry. The other is to use the quadratic formula. I stated in that video, in class I teach to use the quadratic formula, then divide the results by 2 because my students need practice with the quadratic formula. But if you want to use the axis of symmetry formula, I recommend it. So I'm plugging into that, as you see it, fighting away with my tablet pen. And now I'm going to plug that into the calculator as I see it. And the answer I get from my calculator is 4 seconds. From here, I am going to plug in my results into my quadratic equation. I feel obligated when I make these videos to point out that you need a good calculator to do this. A good calculator is not expensive. You could buy a good one for about 20 bucks here in the US if you're watching this somewhere else. And it does a lot of this hard work for you. So for example, with my TI-36X Pro, I can plug this in to my calculator exactly as I see it, and I will get the answer I need. Some weaker calculators, you have to use different symbols, and it becomes a little bit more difficult to do. It is definitely worth investing in a good calculator that has either Math Print, and I believe Casio now calls their displays textbook print, which is just great. The Casio 115 ES or 300 ES are both wonderful calculators that I highly recommend. After plugging this in, I have 256 feet. So here's some thought. It took 4 seconds for this toy rocket to get to 256 feet high. What's nice about these problems is you can actually stop and think about what kind of rocket we're dealing with here. This is probably not one of those little stomp rockets that we push on with an airbag. This is probably one of those toy rockets that use ignition and reach 256 feet. That's the cool stuff about these quadratic problems. We could actually think about them physically. All right, let's take a look at the next problem. So part of the reason why I skipped the quadratic formula in the first problem was because I knew I was going to have to do it here. So in this problem, we have a golf ball that's being launched, and we are going to try to figure out how high it went. Now, a couple of things to keep in mind. Yes, a golf ball goes forward. The other thing to keep in mind, we don't care, because all we want to know is how high the ball went. And I should point out, because we don't have C is 0 in this case. I am going to plug in, for the first part, 25 in for H, and then I'm going to have to set this equal to 0. So let's get started with that. Now what I'm going to do is I'm going to subtract the 25 to both sides. The 25 will not combine with any of the other terms. So I'm going to end up with 0 equals negative 5t squared plus 32t minus 25. And now I'm going to plug into the quadratic formula. So this is negative 32 plus or minus, then square root, if I could draw that. There we go. I am legitimately not writing with this tablet. I am drawing, so it's a little bit funny, as you guys can see. And then negative 5, negative 25. In my previous video, I made clear that you really want to take the time to plug into the discriminant. So let's get that in the calculator and see how it looks. So I got 524 under the square root. If I would have gotten a negative number for the discriminant, that means that the object, I should say, or in this case the golf ball, would not have reached 25 meters. Now that I know the object reached 25 meters, I plug it into the calculator, and I got 91 seconds for the positive part, or the positive side of the quadratic formula, and then I got 5.49 seconds for the negative. So this object went up to 25 feet at almost a second, and then it came back down to 25 meters, 25 meters at 5.49 seconds. So this ball should be in the air for quite a while. Let's take a look to see how long. So I'm using the same quadratic formula I did before, but now I'm going back to the original C, which is 0, and I'm going to plug that information into the calculator. Let's take a look and see what we get. So one thing you may be asking is, you know that the object is going to hit the ground, why did you still plug in the discriminant first? Well, the answer to that is that I could break this into a couple of sections, and it's a whole lot simpler to plug into the calculator. If I try to plug in that whole original equation or formula into the calculator, I could make a typo. And by reducing the number of things I have to plug into the calculator, it's a little bit simpler. Now let's see what the calculator says. So the first answer I get is 0, or 0 seconds. That makes sense since the object started on the ground. It landed in 6.4 seconds. Okay, there is just one more thing I want to show you before we move on from these two videos. Okay, the last thing I want to show you is the actual graph of our golf ball that our little hamster friend smashed into the air. When we work with functions, true algebra, which we don't always get to do at the high school level, is modeling a physical phenomenon with numbers or equations. And the physical part that we see is the graph. So in this case, we did some work with the quadratic formula, but then we didn't physically look at the graph, so let's just take a second and look at that. So here's our first part. There is our time. That's 6.4 that we found when the little hamster launched that ball into the air, and it took that little ball 6.4 seconds to hit the ground. 51 meters is the ball's highest point, and it took 3.2 seconds to get there. Now let's take a look at how we look and see the height at 25 meters. So I added the graph negative 5x squared plus 32x minus 25, which we put into the quadratic formula. What you could see is that the blue parabola shifted down from the red parabola. But the blue parabola did not change shape. It's still the same shape. So it makes it a little bit easier for us to see where the object crosses 25 feet by moving the object down the y-axis 25. If we look here, as I try to drag my mouse over on the red parabola, it's a little bit difficult to do, but at about 25, I have the same decimal as the point at which the blue parabola crosses the x-axis. So it's just a method of moving the object down so that we can more efficiently read it. Alright guys, I hope this kind of gave some insight into what quadratics do. Again, we're still working on quadratics in the elementary level. Not to suggest that that means that they're easy. I just hope that you have a little bit of perspective of the physicality behind quadratics. And also how hard a little hamster can hit a golf ball, because that was pretty incredible. Alright guys, I hope you guys found this video helpful.